Good afternoon, students. Today we'll be discussing another variant of bottom-up parser, which is known as Euler-1 parser. We'll start with a brief recapitulation of the ideas of bottom-up parsing, and then we'll go to the planning and methodologies of Euler-1 parser. Of course, in between, we'll see how and why Euler-0 parsers are not sufficient to parse a programming language. So, I want to encourage all the viewers of this lecture video to just view once my lecture video on Euler-0 parsing immediately before they start looking at the lecture video of this Euler-1 parser, because many concepts which are discussed in the Euler-0 parsing will be required in Euler-1 parsing. Therefore, it is advisable that you know about the Euler-0 parsers before you come to the Euler-1 parsers. So first, a brief recapitulation of Euler parser as such. As you know, Euler parser scans the string, the sentence from left to right, and it mimics the reverse of the rightmost derivation. That's why it's called the bottom-up parser, and therefore it's Euler parser. Euler-0 parser basically means that we are not doing any look ahead of the input while constructing the parsing table, while Euler-1 parser basically means that we are looking ahead by one symbol while constructing the parsing table. Of course, the driver of the parsing table, as you know, there is a driver of the parsing table which uses a stack. That driver does not change much between Euler-0 and Euler-1 parsers. We'll talk about them in detail as we come along. So let us look at the bottom-up parsing basic recapitulation. As I said, it's an Euler method. Then there are other Euler methods as well. In a bottom-up parsing, if we have the grammar and we have a sentence like this, you can see that A, B, 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 C, D, E. Now I want to find out a handle. Now a handle is a substring here, which when replaced by one of these rules, so therefore the handle must be the RHS of some rule, but any RHS of any rule is not a handle. Some RHS of some rule which replaced by the corresponding left hand side of the rule, if it takes me to the previous sentential form in the rightmost derivation, then we say that that substring of the sentence or sentential form is a handle. For example, in this sentence, the handle is this B, not this B, not anything else but this B, because once this B is replaced by this capital A, I go to the previous sentential form from the last sentence. Now from this sentential form back to the previous one, we need to replace this ABC by A. So this ABC is the handle in this sentential form. If I go to this sentential form, D is the handle, because if I replace this D, then I come to ABE, which is the previous sentential form from here, and then I have the whole string as the handle, and that is replaced by S. And once I come to S, we know that we have come to the root of the tree, root of the parse tree. You can see the construction of the parse tree as well here. This B was replaced by this A, then this capital A, capital small b, small c replaced by this capital A. So now the string is small a, capital A, DE. This D is replaced by capital B. So what is the sentential form now? Small a, all the roots of the subtrees. The subtree would be just a leaf. This is the root A, small a. This is the root capital A. This is the root capital B. This is the root small e. So this is the forest. In this forest, the roots of these trees, if I collect them from the left to the right, that gives me the present sentential form. And now, so this small a, this capital A, this capital B, and this small e are all clubbed together to a capital S, because there is a rule like that, and therefore this is called the construction of the bottom-up tree, but construction of the parser in a bottom-up manner. So that is what we have done. I believe that you remember now the term handle pruning. Handle pruning is a must. I mean, I have to get the handle, and I have to prune it. Pruning means replacing the handle in the sentential form by the corresponding left-hand side of that particular rule. Now, so finding out the handle and finding out the correct rule to reduce it are the two challenges. And I think you remember that in LR0 parsing, we constructed a DFA so that these handles can be found out. The basic technique to find out these handles was to find out the longest viable prefix. Given any sentential form, the prefix which does not go past the handle is the viable prefix. Like in this sentential form, small a is a viable prefix, small a capital A is a viable prefix, small a capital A small b is a viable prefix, small a capital A small b small c is a viable prefix, but small a capital A small b small c small d is no longer a viable prefix, because I have gone past the handle which is capital A small b small c. So if I can find out the longest viable prefix given any sentential form, then I know the right end of the handle. Now from the right end of the handle, I consult the grammar rules to find out what could be my actual handle, or what could be the left end of that handle as well. So to find out the right end of the handle, or to find out the longest viable prefix, we have a DFA, and that DFA also helps us in finding out the left end of the handle, and that is how we get the handle and then I prune it using a particular rule in the grammar. So exactly that's what I have talked about. I also said that this is not a handle because although this occurs as a right hand side of a rule, but if I change this small b to capital A, then I get small a, capital X, small e, which is not the rightmost sentential form. Previous rightmost sentential form from here. So here to here, I do not get a small a, capital A, right? So therefore, that is not my handle. So any LR parser has a basic model. So I have the input, which is my program, and which will be terminated by a particular special symbol $, and I have a stack, right? And the driver or the parsing program has a few actions. So it looks at the top of the stack, and the top of the stack is the current non-terminal. This is the current non-terminal uh, which is there, and or the current symbol that is there. Sorry, and the top of the stack contains a state. What is that state? We'll talk about it. And this particular table is maybe constructed by LR0 method, which we have seen, maybe constructed by SLR method, which we have seen, can be constructed by LR1 method, that is what we'll be seeing now, may be constructed by LR1 method, which we'll be seeing a bit later, maybe the next class. So, therefore, the configuration of the state of the parser is the content of the stack from the bottom and content of the input from the remaining input from left to right. Right now, what we look at is the current state and the current input symbol and take a decision. The decision could be shift, the decision could be reduce, the decision could be accept, and the decision could be an error. So if the decision is an error, the table does not contain any entry. Now if it is shift, then actually the current input symbol will be shifted onto the stack, and the next state of the stack uh, mm, will become another state S. And which is this state? From this state, which is a set of items, if I go to using this symbol AI, the place where I go to, the state where I go to is this state. Or I can see that in the top of the stack, the handle is already found. If the handle is already found, then I reduce using that particular rule. So if beta is my RHS, then the stack contains twice the number of symbols in the beta, because every symbol has another state along with it, so a state information along with it. So it pop out twice the length of this beta, and then after that I must have a non-terminal at the very top, and then I have to push the state S, where I could go from the last state using this particular non-terminal that I also push onto the stack. All these were discussed in great detail in my last lecture video, and I always encourage my students to go to that video if they forget about them, because without this basic information, the next part of the presentation of the video will not be easily understandable. While I mean, all of you have that lecture video with you, so if you find out anything uneasy here, then please go back to my previous lecture video, which is on error zero or SLR parsers, and then come back to this video once again. So first, let us see what kind of conflict or ambiguity that SLR parsers or SLR grammars cannot handle, cannot overcome. This is a very simple grammar with five production rules. S is the starting symbol. This is for a pointer. I mean, if you know about C-style pointers, then this is actually about a pointer. So now, I mean, you know that how to create the first set of items, which is I0. I augment the grammar using some S dash produces dot S. This dot is the item marker. Since it precedes a non-terminal, I have to look at all the rules where this non-terminal is at the left. So there are two rules here, 1 and 2. So I put them here. S produces dot L equal to R, and S produces dot R. Again, this dot precedes an L, and therefore I have to incorporate the rules, production rules, in which L is at the left hand side. So there are two rules again. L produces dot star R and L produces dot ID. Also, this dot precedes some R. Therefore, all rules which involves R at the left hand side must be included here. So R produces dot L is also included here. That is the closer. That is the closer of the set I0. Now from I0, if I just use go to L, from I0 go to L. So where do I go? I have two items here which are used to make a go to. So I have seen that S produces L dot equal to R and R produces L dot are the two items in I2. None of these items dot precedes any non-terminal, and therefore its closure basically means only these two items and nothing else. Now, if you closely look into this item, you'll find out in the parsing table, in the column for this input symbol, this item will tell you to shift. To which state is a different question, forget about that, but it will ask you to shift S. And this item will say that actually I have already seen the handle, and therefore please reduce using the rule number 5. So in this parsing table, in the column for item 2, I mean row 2, and sorry, in the row for row 2 and in the column for equality symbol, I get a clear conflict which is known as shift reduce conflict. One item tells me to shift, another item just tells me to reduce. Now, most unfortunately, a follow of R contains this equality symbol. Follow of R contains this equality symbol, and therefore it is even more difficult. I mean, of course, therefore I mean, even in LR 0 and SLR, whatever be the parser, we have a conflict. However, this grammar is the correct grammar, and such a small grammar could not be handled by our SLR parsers, right? So therefore, I see that there must be there is a need to go to a higher order or a more powerful parser, so that simple constructs of the grammars can be easily handled, right? So that's what it